Hi friends, in the last two sessions we learned how to use wire commands, inserting multiple burrs, trimming wires, edit wire numbers, move wire numbers, code command, and also inserting components through icon menu, editing components, swap command, everything. Now, in this session, we have a drawing, not one drawing, we have few drawings that is basically of a drive, electrical drive. The circuit is already here. So what I am going to tell you is how to link between few drawings through source and destination arrow. And there are few tricks which will help you while creating big projects. Let us see what this circuit is all about. This is basically a drive panel with a MBCB, semiconductor fuses, line choke, power contactor, then the drive, again semiconductor fuse on the output side. This is basically a DC drive. AC input is giving, see the incoming is 3-phase AC supply and the output is DC. This is basically to drive DC motor with armature and field. This is the armature circuit and this is the field circuit. The bottom one, this is the encoder. Encoder, see the encoder is mounted in the shaft of the motor. Through the encoder we can adjust the speed and all. This is how the input contactor picks up. This is just a control scheme. You don't need to bother about the control scheme and all. And you can see there are already some source and destination arrows. In fact, I have copied these drawings from a particular project which I have done in the past. This is the basic power plus few controls in this sheet. If you go to the next sheet, this is again the part of that drive. This is the IO card, input output. There are some certain cards inside the drive with a few digital inputs. These are all inputs. This side DI, CUC, DI plus 24, DI1, DI2, DI3, DI4, DI common. These are all inputs, and here you can see few outputs as well. Outputs, in fact, it was here. These are relay outputs of this particular drive. Okay, this is the IO card, part of the first sheet, and this is again a control net card. I mean, you know, in a lineup there may be many drives, so all the drives we can control through Ethernet, control net, and so on, so on, so on. So in this case it is controlling through control net. So the first two sheets are part of a drive. If you go to the third sheet, this is basically a distribution with a 110 volt AC incoming UPS supply, a few MCBs, power supplies, transformer, and all there. This is PLC supply. Okay, and this is a 24 volt AC transformer, 24 volt AC transformer. The output which is using for cobalt circuit, there is a typical control circuit in this particular sheet, that is cobalt circuit, and we are using this particular transformer for that control. And again this one, you see the e-stop supply, this is for emergency control supply. And AC panel, AC fan, power socket, panel illumination lamps, fluorescent lamps, door switch. This is basically a power circuit of this particular panel. And next sheet, this is again the power supply of the control logics, and here you can see these red lines, these red wires. This is basically control circuit. This first one, 110 volt AC supply, here, this is basically an emergency circuit. So 110 volt AC we have to feed here from the previous sheet. If you see here, this is basically 110 volt AC supply. This is, so this is top, this is top is basically for controlling that particular circuit, this circuit. And if you see the bottom here, you can see 24 volt AC supply. This is basically cobalt circuit. Okay, so from the previous sheet we have to feed 24 volt AC supply to this circuit, and see, there are some open wires in this circuit. You can see, basically we should connect some outputs, PLC outputs at this point. What it does mean is, when we provide a 24 voltage supply, the phase will come here, and from here it will go to one relay board, and from there it will come here and pick up this control relay. That is basically the circuit. And what I mean to say again, we have to put a relay in between. That is not in this sheet. The relay we are going to shown in another separate sheet. And again here you see 52 CR1, 52 CR1, 52 CR2, 3. These are all contacts of these relays: 52 CR1, CR2, CR3, CR7, CR4, CR5. These are some control relays. So I have terminated the potential free contacts of those relays also here. So maybe you may feel little bit complicated. Don't concentrate on the circuit. Okay. This is again a digital input card. If you see, this casting machine e-stop relay, shear e-stop relay, mill e-stop relay, the first three inputs. Here what basically we have to do is, at these 3 points and these 3, this is cobalt detector zone, strand 1 to 2, strands 3 to 6 and 7 to 10. Okay, 1 to 2, 3 to 6, 7 to 10. This is e-stop. Basically what we have to do is, from the previous sheet we have to give a feedback to these input cards from the first 3 relays: 1, 2, 3, and this is a cobalt circuit, 4, 5 and 6. We have to give NO contacts of this particular relay to this input card. This is one side, and the other sheet, which is a output card. Here you can see the first 3. Just to concentrate on the first 3 only. These are basically outputs. See, strand 1 to 2, 3 to 6 and 7 to 10 relay. These outputs, where these outputs are basically these points, these 3 points. This 24 volt AC supply will go from here, the first one, this line go from here, and it will come at this point here, and through this relay contact it will go back again to here, here. From here it will go to that relay, and from that relay it will come here. So through the PLC, actually the coil of this particular relay is connected to the output card. So when it gives a command to this relay on, when the PLC give a command to this relay on, this will get NC and this circuit will get closed, so that CR4 picks up. This is basically the control. And similarly the rest too. And the same way, what we have to do is we have to provide a feedback. जैसे ये on हो गया तो we have to give a feedback to the PLC also, that is input. That should go to the input card saying that yes, this is on. So we should give one NO contact of CR4 to here. This is strand 1 to 2. If you see here, this is strand 1 to 2. This contact will go there. This is all about, the putting some contacts here, there, source, destination and all. In fact, one more thing is here. Here also we have to put a relay contact, so that through that relay this control circuit will get activated. So what I am trying to tell you is, sometimes we may not be clear about this circuit, because see, still now I am not clear. I have just written E-stop from field. I don't know from field where it is coming. So I am not clear about this circuit. In this case, I know little bit, and many times what happens is we may not be quite sure what is to be the control logic. How do we control the system? But we cannot hold the designing the other parts just because of one circuit. In that case, what happens is our manufacturing will get stuck. So we have to proceed with the manufacturing without this circuit. Once we get the input from the customer end or from other end that yes, this should be the control scheme, then we finalize the scheme and we create the scheme. So what happens is, sometimes we may create hundreds, 200, 300 sheets without this one circuit. And the problem is, in fact, all these circuits have an interconnection like this. This is part of one drive. Here I don't know where it is coming from. I have left it blank, and I have made hundreds of such drawings with a blank. There is no source arrow, destination arrow, nothing. Okay. Then finally I created this drawing. Then it is not possible to go to each and every sheet individually and put in source, destination. Yes, we have to do that, but there are some tricks just to do this. So we will cover this portion as well as the basics of putting source and destination arrow. First, let us move to this sheet. This is our main sheet now. Okay. Here we have to give 110 voltage supply. This path I have created just now. Fine. 110 volt AC supply I have to create. This is already made circuit. I know I have to feed from here. E-stop supply. This is 110 volt AC. This is my E-stop circuit. So I will put a source arrow here. Source. I know this is my phase, because you see here, you see 110. This is my phase, and if you see here line, it is connected to the bottom line, that is this line, that is my phase, this line. So I will put a source arrow here. saying my emergency circuit is in 52, sheet number 52. So I will put 52 110 P1. You can put any code, but there should be some logic, so that if you are creating just one sheet, you can put something. When you create hundreds of sheets, there should be some logic, so that will become your standard, and it will be very easy to follow. So this is the standard I follow. From to sheet number 52, I am providing 110 volt phase. So I put 52 110 P1. Okay. It is asking insert matching destination arrow now. I don't want to insert it now because it is in the next sheet. So I will say no. Now in the bottom line I will put 52 110 N1 neutral. No. This time also I will say no. And for Cobalt circuit I have to provide 24 volt AC from here. Here also I will put 52. This time it is 24 volt. 24 P1. Okay. No. 52 24 N1. Okay. No. Done. Now I will move to next sheet. I know here it is 110 volt. Here I will put destination arrow. This is my phase. You should always leave phase in this way. I mean that will go to the field and return from field. Negative will neutral will directly go to the coil. 52 110 P1. Okay. So here you see one or more wires on destination wire network do not match the wire layer tied to the source. Do you want to update to the destination wire layer now? Because in the previous sheet the layer was something different. Where we put the source arrow, the layer was something different. Source layer was 0. Here it is in a different layer. So it is asking, do you want to match? If I say yes, this will become also layer 0. This is wrong. I can tell you this is wrong. You should never make any drawings with different layers like this. See, now it has become layer 0. Still the wire number is here because of this property. See, the 0 is here. If you want to remove 0, you should select 0 and remove layer. So at the beginning, when you start a project, you should make sure only the wanted wires are there in this particular field. But unfortunately in this drawing there is something wrong. Anyway, that doesn't matter. So I put 52 110 P1 here. Now I have to put here as well. If you don't remember exactly what you inserted in the source code, you can pick from here also recent. So you will come to the yes 52 N1. Okay. Okay. Same question again. Layer difference. Both are different layers. So it will ask you whether you want to convert this particular layer into the source layer. If you want yes, if you press yes, it will become 0 layer. If you press no, see, now this time I have entered no, so there is no change. Same way, coming down here, I will put, I don't remember, go to here, 52 24 P1, it was there. Okay. Again the layer question, no. Recent 52 24 N1, okay, no. So This 110 volt AC source destination and 24 volt AC source destination is over now. You can see the ferrule numbers are coming automatically here, all the ferrule numbers. If you go back to the previous sheet, here it is not updated. If I do the wire numbering again, you will come to know. See, now it will see, now it is see. So sometimes you may require to do a source signal update. Now going back to the input card, let us go to the input card here. Here what we record is there are 3 e-stop inputs we have to provide. 3 e-stop. This is the first set. This is through a timer. The first one is a timer. Through timer I am controlling the first e-stop relay, and through the second timer I am controlling the second e-stop relay. Through the third timer I am controlling 2 relays are here. You can see 2 relays because basically I have considered 1 relay only initially. That relay was with 4 NO contacts, but while making the schematic diagram I came to know that I need more contacts, but unfortunately I have ordered 1 relay with 4 NO contacts. In that case what I have done is I have inserted 1 more relay in parallel with this particular relay. Okay, so basically my control is 3 relays in this circuit, in this top circuit. The circuit is simple. This 110 volt will go to the field. In the field there may be a emergency stop push button somewhere in the field. That is normally NC only, normally closed. So it will go to the push button, will come here and will pick up the timer. Okay, timer, see, you can see the NC of this timer is here, and through this timer we will pick up this relay CR1. Once the CR1 gets picked up, okay, you can see the contact here also. It will go to the drive, and also one of its contact will go to the digital input card. So now first I will put a contact here in this digital input card. I know with the IO description I know the first relay should come here. Feedback of the relays, NO contact I am going to put here. Project 52 CR1. I know this was that relay. Okay, 52 CR1, it is here. Now if you want to insert more, now I want 52 CR2. Drawing, if it is coil is in the same project, same sheet, you can choose the drawing option. This is the project CR2. Okay, I want one more. Now this time instead of inserting I am through the command line, I am applying a command AE copy component. Edit. In fact I will straight away put 3 also. This is also one of the options. Now the cross reference is not there. You can see the first 2 it is there, but in the third it is not there. Don't worry. So I will connect a see, in this case you can note one thing. I have connected to this particular point. This is some 110 volt AC is coming from some other source. So basically what I did is I have used one NO contact of all the three relays here. So once that relay gets picked up, the card will get a feedback. The PLC card will get a feedback. This is one way. In the same way, here also we can put here. Here also we can use the NO contact of these three relays. Strand 1 to 3, 4, 3 to 6 and 7 to 10. These relays can be inserted here. So in that case, I'm not going to insert there, but this supply, this is basically what practically do is this will be looping from one point to another. So all these relays will be physically in one location. So looping is the best way. So here I will put again a source arrow here. This is my sheet number 55 110 P1. P1 I don't think somewhere, yeah, I have used it P1. So I will put P3 here. P1 and P2 I have already used in this drawing. P3. See, now this is linked. Copy. This is my fourth. Okay, repeat. This is my fifth. I know these numbers because I have designed the circuit. This is my sixth. Fine. So you can see the 110 volt AC supply phases I am getting somewhere from here from somewhere. So I am looping that supply through these relay contacts from one contact to another, and from here to here. Okay. In fact, if this IO list, these descriptions were here, I should not have used the source or destination arrow. I can loop it continuously. But this list is provided by the customer, so I cannot put it as my fancy. So I have to follow some norms. So this is input. So using this component cross-referencing, we can do OK project. Now you see here you can see the cross-referencing you can see here everywhere, but in fact if you go here you cannot see those cross-reference. Now for that I have to update. Now it will come everywhere. This is input, and output also. See, here we have to provide 3 outputs. The outputs are going basically from here 1, 2, 3. First set is this, second this, third this. One wire will come from there, it will get terminate here, and it will go from here and will get terminate there. That is the philosophy. So what I will do is, I will, instead of going here and there, first putting here then going there, instead of that I will do one small trick. First I will put a destination. This is my 58th sheet, 58 DO1. Okay, destination, and not this one. Now I put this 58 DO3. Now this one 58 DO5. These are my destination. 135 is my destination. Now source I will put 58 DO2. No. 58 DO4. No. 58 DO6. No. So if you cross check this, this is 1 DO 58 DO1, this is 2, this is 3, this is 4, this is 5, and this is 6. 1 to 6. 2 per relay. Okay. In the first one, where this it is D1, this is basically a destination. Remember, this is destination, and DO2 is source here. But in the other sheet, I have to put it in the opposite way. In the other sheet, it should be opposite way. That means in the other sheet, DO1, 58 DO1 will be source. Here it is destination, there it will be source. So let us move on to yes. Here what I will do, I will put source arrow here. 58 DO1 is my source. No, I don't want to update now. 58 DO4 3. If you don't remember recent, you can see here I put 3 there. DO3. Okay, no. Recent DO5 I put there 5. Okay, no. See, once you pick in this way, you know, so see, this already put the cross section, but here cross reference, but here it is not there, but we can do it later. Now this 1, 3 and 5 is over through source arrow. Next I will choose destination. I know 58 DO2 is 2, 58 DO4, 58 DO6. If I do the wire numbering, individual wire, if I now you see it is going to 58 from 58. These ferrule number you find 5841, 5861, 5881. Okay, you will see these ferrule number in sheet number 58. Yes. Now it is not here. You can see the question mark because we have not updated. Drawing weight, individual weight, project weight. Once you complete all the project, you can do it project weight also. But that will take some time because if there is more drawings, it has to read all the database. So instead of avoiding the delay, I am picking only the individual wires here. I have not picked this one. You see. This is 5841, 61, 81. Now this circuit is through. This is one way of putting source and destination arrows. Now you can see this relay, the one contact is used here. I have terminated here. This should basically come between these 2 points. So what normally I do is, while making these drawings, particular this one, what I will do is I will put source arrow 1 based on the sheet number of this particular sheet, 7 DI1. This is basically a digital input. No, and one destination I will put 7 DI2. Okay, so while making the first drawing I will put this, then I will save as, and if I have 50 drawings, 50 such drives, I will save as and I will change the tag. So this tag will change. When now at present this is 7, when I save it into 12 and when I update the tag it will become automatically become 12. 7 will become 12. I don't have to change it. So in this fashion I make the initial drawings, and finally when I make this circuit, what I will do is I will put here in the opposite way. I don't have to go to all other sheet. 7DA1, 7DA2, and if this is going to sheet number 12, in fact I have only one drive drawing now, so I'm not putting here. If it is going to second drive, I will put 7, and it is going to 12, I will put 12, 14, whatever sheet it is. So I don't have to jump from here to there and there to here. I have to work only in one sheet. So this is a very easy way. While making the first sheet, you should be very careful. You should assign all the necessary things, because maybe, see, in fact while making this drawing I was not quite aware where it is going, where it is coming. Okay, so what I should have done is I should have put these signals at the beginning. So if you don't have anything in this particular that control scheme, what will happen is this will remain as a question mark. Don't worry. So once you get those detailed final, that one sheet, only that one sheet, and if you do the project wise update, all this will get updated. Otherwise what will happen, you have to go to each sheet individually, go there, draw wires, put source arrow, put destination arrow, next go to next drawing. There also you have to draw the wire, destination, source. So don't do that. While making the first sheet, make it perfect, put everything, and maybe once you get the details, by updating just a single sheet, you can, very well update the whole project. And by chance, if you miss to do that, again I suggest, it is a trick. This is not the basic way to do, but still I suggest it. You can do one thing. If you have same drive, I will just save as, and I will put it, rename it as 12. Okay, 12. I will add this to this project. Add active drawing, yes. I will one more sheet. This is my sheet number 17. I will add this too. Yes. But while adding, you see the sheet numbers, I have not updated the sheet numbers. For that you have to go to the properties, and this is 12. Otherwise, you know what happened, if I don't update, this is sheet number 17. Okay, when I do the wire numbering, all the wire should be with the prefix 0, 17. If it is 17, it should be 17. That is the setting which I applied into this particular sheet. If I do the wire number here, you see drawing word, if I do the wire numbering, see again the wires are with 07 only, 07 only, because I have not updated this thing, drawing property. If I change this, then only I can update. Now if I do the wire numbering, drawing word, see now it is 17. Okay, so now I have added two more drawing. Even now it is, you see in this particular here project manager, it is 7 only. Don't worry, just refresh, that will become 17. So what I have done is I have made similar two more drawings, and assume that we have hundreds of such drawings, and in fact you have, unfortunately you missed to put these arrows there. Okay, so then what you should do is, don't go there and draw lines like yes, going here, putting source arrow, clicking here, source arrow, enter the tag, then go to the destination arrow, enter the tag. That will consume lot of time. So what you should ideally do is, these all these drawings are on same position 0 0. Okay, we have not moved any of this drawing. If you are sure, then you can apply this way. Just Control Shift C, base point 0 comma 0, select objects, just copy these two. Okay, go to that sheet, Control V, 0 comma 0, it is here. Now you just have to edit. Instead of this 7, I have to make it 12. Now go to next sheet, Control V, 0 comma 0, edit. So instead of 7, it should be 17. So by this way you can save a little bit time. Okay, this is a one way of doing. And again, going back to sheet number 52, here we have, we know we have inserted source and destination for one drive only. Now if you want, you can copy component. I'm just copying. This is going to now 12 also, and I want 17. Same way destination is going to 12, also to 17. Now if you do the var numbering, it's not updated. Let us see why. Var numbers, drawing bed. Sometimes this problem comes 7DI1. There is something wrong. So while 7DI1 is source here, 7DI2. Yes. You see, this is the problem. 7DI1, it was source there and it is source here too. That is why if I change this now it will be okay. 2 will become 1, 1 will become 2. This is 2 and this is 1. So these type of mistakes can happen sometimes. So be careful. 2, 1. Now var numbering, drawing wide. Now you see it is going to 7, 12 and 17. Still not here. And in fact you can do it project wise. You don't have to go to here and there just individually. You can do it project wise. Again, drawing wide, if you do var numbering, see here it is there. Now go back, sheet number 12, do the project var number, drawing weight, it will come 17, var number, drawing weight, this will come. So this is what source destination arrow is all about. And before ending this session, I would like to tell you one more thing, that if you have many wires like this is not the proper layer. You should make sure you draw the in wire layer. Okay, I have few wires here. And I want to insert some arrows here. 52 DIG1, digital input 1. and in fact the next one I want to put 2, 3, 4 in that way. So if I copy one by one, or I will put one by one, again it is time consuming. There also you can use this pick master. Just select this through the end, just make like this, keep all, don't ask. See, it is done. Now if you go on here, check here, this is 1, this is 2, this is 3. We see the sequence 5, 4, 5, 6. In this way you can do. So this option is also there. So it will save a lot of time, and some, if you are capable to write some this thing programs and all, you can do, you can save a lot of time. For example, if you see here, you can see 71, it is here, right? Now I am saving, this is in fact sheet number 17, forgot about that. I will go to sheet number 7 now, and I am going to save it as sheet number 22. Before that, you see here, it is 7di1, it is 7di2, okay, and the components, everything 7lpb1, 6e1, 7lpb1, it is all with 7. This is 12, it's going to 12, so for this is 7 again. Now I want to change it to sheet number 22, okay, 22. You go here and you can very well do it with a this project. If you go project, utilities, update tag, component retag, use this, whatever sheets. Now right now this is sheet number 22, that is not a part of this project. I have to first make it a part of this project. Add active drawing, yes. From here you can update component retag and all, you can do from here. Again, this will take some time, because in this it is not updated, because if you see the project properties, there is something wrong with the project properties. Okay, so what I will do is, I will show you a small program. I have a small program with me. I doubt whether that will work in this PC, because this is not my personal PC, and I have just copied it here. Support macro, I have written some macro here. Support macro, open, close, close. No, that is not working here, because you know, through some program, small programs, you can update all this with a single go. Even this thing, these tags inside this 7 will become automatically become, we can convert it into 22. Everything within this will update. Even this 6 will become 21. In this 6 was there in sheet number 7. Remember, in sheet number 7 it was 6, but through writing some programs, when we save us this into sheet number 22, this will automatically become 21. So you can customize the commands as well. Okay, so that is secondary. First you learn the basics, make it perfect, and slowly you will start writing some small Autolist programs. Using that, you can very well save time. So that is all about source and destination arrows, and something new in the next session. Thank you.